22. If K is the mass transfer coefficient and dV is the molecular diffusivity, which one of the following statement is not correct? We have to be very careful here. Not correct. It's not asking for which is correct. It is asking for which is not correct with respect to mass transfer theories. Now, we know the film theory is a very popular one, which was proposed by Whitman in 1923, which basically states that there is a very thin film through there is no turbulence in this film here, and the most of the resistance of mass transfer lies within this particular film. And if we take in general the rate of mass transfer is equal to KL. So let's say this is the mass flux, that means with respect moles transferred per unit time per unit area. Let's say that is Ca1 minus Ca2, the concentration difference. So here this is actually shown as K, this K here, not KL. So we know according to film theory, K is equal to dAB over delta, and therefore K is proportional to dAB. So this is one, and dAB is written here as dV. So this particular one is correct. Okay, penetration theory. You know that according to penetration theory, let's say there's a mass transfer, so let's say liquid and this is a gas, and let's say this is liquid. We assume that the packets of fluid just go up to the surface and gets exposed for a fixed time. Let's call that exposure time as Tc, and then it gets there's a mass transfer, and then it comes back here and another packet goes up. That's basically the theory of penetration theory. It was first proposed, the mass transfer coefficient K is equal to 2 square root of dV over pi Tc, where Tc is the exposure time. So as see, according to penetration theory, K is proportional to dV raised to the power half. But here it shows dV to the power third, so this is not correct. We'll look into the other one, surface renewal theory, which is a modification of the penetration theory, because penetration theory assumes a constant exposure time Tc, and there in surface renewal theory, that was surface renewal theory, and that was by the famous scientist Danckwerts. I think that was in 1951. Here it assumes that there is a distribution of the exposure time, and there is something called surface renewal rate, and according to this one, K is proportional to square root of dAB. Let's call this as dV S. So where S is the surface renewal rate. So again here you see that K is proportional to dV to the power half, which is correct here. So this is also correct. How about D? In the D, this is in the boundary layer theory. It basically assumes that the mass transfer is the maximum resistance is offered by the laminar sublayer there, and there's a hydrodynamic. So here's the hydrodynamic boundary layer, and that's where the resistance to mass transfer lies. And so basically here also the velocity gradient, here velocity gradient and the concentration gradient lies. So according to this theory, we find that we have given you the details in here, that this is the expression for rate of mass transfer. So here K is proportional to dV raised to the power 2/3. dV raised to the power 2/3. This is given in the in our solution in our website. So basically, according to this one, so what we see here, according to boundary layer theory, K is proportional to dV raised to the power 2/3, which is also correct. So which one is not correct? This is, so option B is not true, so therefore this is the correct answer. Right here. Film theory predicts K is proportional to dV directly, which is raised to the power 1 according to film theory, whereas according to penetration and surface renewal theories, K is proportional to square root of dV, that means 0.5. Actual value lies between 0.5 and 1, somewhere around 0.66 and 67, which has been experimentally observed. So boundary layer theory is very close to the actual experimental result.